All right, ladies and gentlemen, let's topic today are nuclear reactions. We're talking about alpha, beta, and gamma reactions, but now we've got two other types that we're going to deal with. Our first type, and here we have more doodle notes. Our first type is a fusion reaction. We'll have fission and we'll have fusion. So fusion is first, and now nuclear fusion. Anytime we talk about a fusion reaction, that's joining two or more things to create one single thing. Nuclear fusion, that's when you have two small nuclei and they join together to make one larger nuclei. Maybe with a few other extra particles. Now this releases an incredible amount of energy due to the conversion of mass. If you remember, the mass will get converted to form binding energy, with some of that energy is used up for binding and just gets released. And so because it produces so much energy, we're trying to create fusion reactors. Now we see a fusion reaction of time, for example, in the sun or other stars. Isotopes of hydrogen in high temperatures and under a lot of pressure due to a magnetic field will fuse to form helium. And so this is how most of our elements get made. So fusion will occur in small iron. Now, feel free to pause here and get all of the details. Okay, so let's talk about fission. Now, fission reactions are when they split apart and break down into smaller parts. Nuclear fission is when we get a nucleus breaking down into smaller atoms. And this usually occurs in atoms larger than iron. And if you scroll back up for a second, and a lot of times, if we get unstable atoms bombarded with neutrons, that's kind of like the thing that gets it going, primes the pump, so to speak. And so this energy can be converted into electricity when we use uranium in fission reactors, because a lot of the energy gets released. And so space probes will use fission as a heat source. And again, feel free to pause this to get all the details. Okay, so this is the filled in version. Feel free to color this and doodle on it as you need to. All right, so for this are our practice. I'm going to do one with you guys just to show you how it works and to explain how you can tell if it's fission or fusion. We're going to do number one. Now, if it's fission, we're going to have one bigger molecule and it's going to split into two smaller ones, like this one here. If it's fusion, we'll start with two and it'll become one. So kind of like look at number 3 or 4. Now, this is going to be very similar to our alpha and beta because our numbers have to add up. Now, we're assuming that there's no byproducts like neutrons or protons or anything like this. Okay, so we're going to keep it simple. So this means that for my atomic number, 91 on the left is got to be equal to 77 plus some other number. Okay, so if I do the math on that one, that should mean that I should have atomic number of 14, which means silicon. I'm going to do the same thing for the mass number. So 231 has got to add up to 192 plus my mass number, which I symbolize with 8, which means that my mass number should be 39. Okay, so why don't you guys try the rest, the other 8, and if you have any problems, feel free to contact me, whether through EDSBY or wait till I get back, and we'll get this figured out. All right? We'll see you guys in class. Bye.